This is the lesson for the unit circle, lesson 8.5. You should have a paper that you have a circle on, and it should have an XY axis drawn through the center. So if you do not have that, then you need to pause the video and either get that paper from me, or you can get a regular 8.5 by 11 plain piece of paper. You're going to draw a circle almost as big as you can. You want to leave a little bit of space around the edges, and then you're going to draw an XY axis through the center. So use a compass or something to draw the circle. Okay, now that we're ready, we're going to learn today about what's called the unit circle, and the unit circle is a really important idea in trigonometry. And so on this circle, what we're going to do is we're going to start bringing together some of the things that we've learned before. And so the first thing we're going to do is we're going to start by labeling the four axes. So this is going to be 0 degrees. This one is 90 degrees, 180, and 270. And then, of course, this one goes back to 360 when you go all the way around. So those are the most common numbers. And now let's go ahead and draw the 45-degree angles. So the neater this is, the better it's going to be and the easier it will be to use. And so if you've got a straight edge, I want you to get a straight edge. And you're going to, I can't quite zoom this out far enough, I don't think, to do this, but you want to draw a line right through the center of the first and third quadrants that goes through the origin. So I can't do it with a straight edge on this for this video, but you do that. And then we're going to do the same thing through the second and fourth quadrant. So halfway through the quadrant, through the origin, through the other quadrant. Whoops. Okay, and you want the lines to kind of come out a little bit beyond the circle. Okay, now that you have that, let's label 45 degrees. This is, so 45, 90, and then it's going to be 135. And then after 180, if you add 45 to that, this is 225. And then add 45 to that, it's 270. And then you add 45 to that, and it's 315. Add 45 to that, and you're back at 360. Okay, I'm now going to switch colors. So you want to get a different color. And what we're going to do now is we are going to draw some 30-degree angles. And so I want to draw this angle right here that's 30 degrees. Now we're not having to measure, we're just sketching here. But if you think about it, if this is 45 degrees, then 30 degrees is only like 15 away. But I want to give it enough space so that I can see what I'm doing. So I'm just sketching about right there, we'll say. And so if you can do a line straight across, like we did with the 45 to go through the first and third quadrants, then that's going to be what we want there. And then same thing with the 150 degrees. So we're going to do the same thing like that. So these are our 30-degree angles. So all of these have a 30-degree reference angle. So we've got 30 degrees. Now we're skipping past the 60, the 90, the 120 for now. We're going to come back in a minute and do the 60-degree angles, but let's just do the 30 degrees for now. And so this would be the 150. And then 180 plus 30 is going to be 210. And then 360 minus 30, that's going to be 330. Okay, so that's what I've got so far. Okay, the next thing I'm going to do is I'm going to change colors again. And now we're going to do the 60-degree angle. So the 60-degree angle is, of course, can be another 15 degrees past the 45. And again, just like the others, I'm going to draw straight through the origin, through the other quadrant, so through the first and third quadrant. So get a ruler, and we're going to make this 60-degree angle. And preferably, you can do it all in one line to make it all through the first and third quadrants. And then we're going to do another one through the second and fourth quadrants. Now in reality, if we were doing this, like if we got a protractor, the 45-degree angle would be right in the center, and then the 30-degree would be like right there, and the 60 would be right there. There would be more space between here and here than what we're seeing in our picture up above. And there would be less space right there than what we're seeing up above. I'm doing it this way because we're going to need to do a lot of labeling, and so we need the space anyway. And so just to make that work for us, it's okay to have them not be quite to scale. Now this is going to be 60 degrees. And so then if I add another 60 degrees, I end up at the next purple one, and so that would be 120 degrees. And another 60 degrees, of course, would take us to 180. 180 plus 60 degrees is 240. And then 240 plus 60 degrees is 300. And then if I go another 60 degrees, I'm back at 360. So these angles that we have marked here, these are all of our main angles that we're going to have on our unit circle. Now obviously there's a million other angles that we could have. We're not doing 5 degrees or 27 degrees or 75 degrees. These are the ones that we use the most with trig, and you need to be able to know this unit circle. In fact, by the time we get to the test, you're going to need to memorize it. And not just what we see here, but there's a lot more to it. So let's get on with it and what we're going to do with this. The next thing we're going to do is we're going to go around and mark with radians all of the measures that we have. Okay, so the radians. So remember that when we have 0, that's 0 radians or 0 degrees, and then 180 in radians. Let me choose a slightly different color. Maybe I'll do dark for that. So radians, this is going to be pi. So remember that it goes 0 to pi. I'm just going to put 0 right there too. And then the 90-degree angles, if this right here is pi, then remember that this one is pi divided by 2. And so that's 1/2 pi, 2/2 pi, 3/2 pi, 4/2 pi. So you're just doing fractions of that. So if I do 1/2 pi, 2/2 pi, this is 3/2 pi down here at 270. Okay, now if we look at our 30-degree angles, okay, 30 degrees is a 1/6 of 180. So it's pi over 6. So every 30 degrees is 1 more pi over 6. So this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So if you just think about it like that, just in terms of 1/6 of a half circle, so this is pi over 6, 2 pi over 6, 2 pi over 6, that reduces, and so we're going to call that pi thirds. And then 3 pi over 6, of course, reduces to pi halves. And then 4 pi over 6, that reduces to 2/3. So we're going to say 2 pi over 3. And then going down to 150, that's our 5 pi over 6. And then pi is 6 pi over 6. So then if we keep working our way around the circle, we go to 7 pi over 6, 8 pi over 6. So 8 pi over 6, that reduces to 4/3 pi. And then 9 pi over 6. So 9 over 6, that reduces to 3/2. So I've already got that labeled. 10 pi over 6, that reduces to 5/3. Okay, as we continue, since we've reduced so many fractions, it's kind of hard to keep it straight. So let me just go back. This is 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. So the next one is going to be 11 pi over 6. And so 11 pi over 6. And then the next one will be 12 pi over 6, which reduces to 2 pi. So we're going to write 2 pi. So if you look at your entire circle, now let's look at the 60-degree angles, the ones I have in purple. So notice I have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. And so when you do this, the 30-degree angles, you're getting the 60-degree angles as well, with the radians once you reduce everything. Okay. All right, now the next one is going to be our 45-degree angles. So again, thinking about in terms of the unit circle, we've got 1/4, 2/4, 3/4, 4/4. So we're going to be doing fourths this time. So this one is going to be pi over 4. And then at 90 degrees, it's going to be 2 pi over 4, which is pi halves. I already have that. Then I'm going to have 3 pi over 4. And then I'm going to have 4 pi over 4, which is pi. Then I'll have 5 pi over 4. 6 pi over 4 is 3 halves, so I don't need to worry about that one. And then 7 pi over 4. And then 8 pi over 4 is 2 pi. So we have now our entire unit circle named in both degrees and radians. And so one thing you need to be able to do is you must be able to reproduce this circle with all of those labels. And so you need to be able to see that in your head and be able to put it on paper so that it can help you do the other things that you're going to be required to do. We will now find the location of point P on the unit circle. We've done that before, so let's start with this point right there. So if this is a unit circle, then that means that this is 1. So the location of that point would be 1, 0. Okay, and then we go to the next one. So let's go to the 30 degrees. So if we're looking for this point P, we've done this type of a problem before too. So if this is 1, if I was to draw the vertical line that creates my right triangle, then this is 30 degrees. And so using your 30, 60, 90 triangle, if the hypotenuse is 1, this is going to be my x and that's going to be my y. So my x will be the longer leg and the y will be the shorter leg. So y is going to be half of 1. And then we take 1/2 times the square root of 3. And so square root of 3 over 2 will be x. Okay, so that takes care of that one. Now let's go to the 45 degree. So again, we're looking for point P. If I draw the vertical line, then I have my 45, 45, 90 triangle. And the x and the y are going to be the same. So whatever one is, the other will be. If the hypotenuse is 1, I'm going to take 1 divided by square root 2, and I want you to simplify that radical. So when you simplify the radical, it comes out to be square root 2 over 2. And so x and y will be the same thing. So that location of point P will be square root 2 over 2 and then square root 2 over 2. Okay, then we're going to go to the 60-degree angle. Okay, and if we draw the vertical line there, we've got a 30, 60, 90. This is 60. Whoops. This is 60, and then this is 30. So because of the 30-degree angle, the x is going to be the smaller number. The hypotenuse is still 1. So the smaller number is the x, and so it's half of 1. And then you take that and you multiply it by square root 3, and that's the longer side. And so that takes care of that location. Now I want you to notice the similarity between the 60 degree and the 30 degree. Do you notice that we're using the same numbers? It's just that they're swapped as far as their location, and that's just because you've got the longer leg being on the x-axis or the longer leg being on the y-axis, and so that's the same type of thing. Okay, if we go to 90 degrees, that location there is 0, 1. So if we go to quadrant 2, then how is that going to change the coordinates? So if I went to 120 degrees, your reference angle, if I draw my line right here, for this point P, my reference angle is still going to be 60. And this will be 30, so I've got my shorter leg is x and my longer leg is y. Hypotenuse is still 1. And so I'm still going to be using the x is 1/2 and the y is square root 2 over 2. So why are they exactly, or not square root 2 over 2, sorry, square root 3 over 2. Why are they the same if it's 60 and 120? Remember the quadrants. Remember that it matters what quadrant you're in. And so if we're in quadrant 2, then that means that my x is negative. So I'm going to have negative 1/2 positive square root 3 over 2. So what this is it's just a reflection across the y-axis of that 60 degrees. So do the second quadrant, pause the video, and I want you to do the second quadrant, the 135, the 150, and the 180. Then play the video, make sure you've got it, and then we'll have you finish up the circle. Okay, you should have finished this up, and so for 135, because it's in the second quadrant, you're going to go left, which is negative for your x, and then up, and it's the same distance because it's a 45, 45, 90. For the 150 degrees, that's going to be the same as your 30-degree angle over here on the right in quadrant 1, but you're going to go negative square root 3 over 2 and positive 1/2. And then for 180, you're going to go negative 1, 0. So if you didn't get those right, then pause and go back and try that again and make sure you're understanding with each triangle. If you need to draw each individual triangle, then that's fine. You want to make sure that you understand this and why and how, because this is a very, very important piece of what we're doing. Okay, if you're ready, then go ahead and finish the rest of the circle. Remember that all of these are going to be dealing with either a 30, 60, 90 triangle or a 45, 45, 90 triangle. So you're going to be dealing with all the same numbers. It's just a matter of location. Which quadrant is it in, and that's going to affect your signs. So pause the video, finish the coordinates, and then come back and make sure you got them right. Okay, what you should have done is for 210, because it's in the third quadrant, you're going to have negative square root 3 over 2 and negative 1/2. For 225, negative square root 2 over 2 and negative square root 2 over 2. For 240 degrees, you're going to have negative 1/2 and negative square root 3 over 2. For 270, you're going to have 0 and negative 1. For 300, you're going to have positive 1/2, negative square root 3 over 2. For 315, you're going to have positive square root 2 over 2, negative square root 2 over 2. For 330, you're going to have positive square root 3 over 2 and negative 1/2. And then you're back to 360, which is still this location, which is 1, 0. Okay, as we look at this, I'm going to go to a different page, just looking at quadrant 1. So let me rewrite just the quadrant 1, because I'm going to show you something that's a really important thing to remember as you're doing this. Okay, if you'll notice, if you look at all of your quadrants, specifically I've got the first quadrant up here, but even if you look at your entire circle, you are only dealing with 5 numbers. You have 0, you have 1, you have 1/2, square root 2 over 2, and square root 3 over 2. Those are the only 5 numbers that you have as far as your ordered pair goes on anywhere in the circle. And so those are really the only numbers you have to remember. These are all dealing with the 30, 60, 90 or the 45, 45, 90 triangle. So those are what you deal with your special right triangles. The 0 and the 1, those are dealing with your x and y axis. And so depending on where they're located, you might have positives or negatives, but those are the only 5 numbers you're dealing with. One thing that is helpful to remember with the 3, the 1/2, the square root 2 over 2, and the square root 3 over 2, this is the smallest number. Okay, if you put that in your calculator, you can see that that's the smallest number. Square root 2 over 2, that's the middle value. And then this one is the largest value. And so when I look at this, it helps me to think that for 30 degrees, I'm going to go over a lot, up just a little. And so that means I'm going to go over square root 3 over 2 because that's the biggest, and then up the smallest amount. And then for 45, 45, 90, I'm going to go over some and up the same amount. That's going to be your square root 2 over 2. And then for 60 degrees, I'm going to go over a little, up a lot, and that's going to be over a little, which is 1/2, and then up a lot, which is square root 3 over 2. My 0 and 1s, those will be reserved for the x and y axis. And if you look at your circle, remember that for your y axis, I wanted to do that in yellow. If you look at your y axis, okay, that's going to be your 0, 1, 0, negative 1. Your x-axis will be the 1, 0, or negative 1, 0, because remember the x comes first. Okay, the next thing that I want to talk to you about, now that we've got this in here, is we're going to talk about values. Okay, so I want you to get your calculator and make sure it's in degree mode. Okay, you don't want it to be in radian mode for this, so make sure you're in degree mode. Okay, once you're in degree mode, I want you to type in cosine 0 degrees. and see what you get. And then I want you to do sine 0. Okay, then I want you to do cosine 30. What do you get? Then I want you to do sine 30. What do you get? Then I want you to do cosine 45, sine 45. And then cosine 60, sine 60. And then do cosine 90 and sine 90. Once you've done all of those, I want you to examine this picture that you have in front of you, and I want you to figure out the connection. So pause the video until you've done that, and then come back once you think you see the connection. Okay, if you put these numbers in your calculator, so if you see like cosine 30, you're going to get a decimal in your calculator. And the decimal that you get in your calculator is 0.866 and then some other decimals. Okay, so 0.866 and something else. And we've already talked about how cosine and sine are always going to be between 1 and negative 1. And so maybe you don't really notice too much, but then you do sine of 30 and you get 0.5. Okay, and so you keep going through, I put those in the wrong spots. Right there, right there. Whoops. There we go. Okay. And then if you do 45, you do cosine 45 degrees, you're going to get 0.707 and then some other stuff. And sine, you get exactly the same thing. And for cosine 60, you get 0.5. And then for sine 60, you get 0.866 again. For cosine 0, you get 1, and sine, you get 0. Are you noticing the pattern? So what you've hopefully noticed here is hopefully you noticed that the x-coordinate, so all of our x-coordinates, so this, all of those, the x-coordinate is the cosine of theta, and the y-coordinate is the sine of theta. And so when we did all of those exercises previously where we had to find the point, the ordered pair, what we were doing is we were finding the cosine and the sine, as long as it's a unit circle. If it was something bigger than a unit circle, then we weren't finding the cosine or sine. We were saying like 4 times the cosine or 4 times the sine if it was a radius of 4. But that's essentially what that is. And so when we wonder what does the cosine mean, it's telling us the location of the x-coordinate on the unit circle. And so if I look back on my whole unit circle that I've got filled in here, if I wanted to know what the cosine of 150 degrees is, I just need to know what the x-coordinate of that point is. So the cosine of 150 degrees is negative square root 3 over 2. If I wanted to know the sine of 4 pi over 3, I need to, number one, know where that is on my unit circle. And then once I know where it is, I can say, oh, it's the cosine is negative 1/2, the sine is negative square root 3 over 2. If you are doing this from scratch, and so like if you're on a test or something and you wanted to do like, what is the cosine of 4 pi over 3? Then you just do this. You say, okay, that's 1/3, 2/3, 3/3, 4/3. Okay, this is 4 pi over 3. And so because it's a pi over 3, that means that this is 60, so I'm dealing with a 30, 60, 90 triangle over a little, up a lot, or down a lot. So negative 1/2, negative square root 3 over 2, because you're still dealing with all those same numbers. And so the ordered pair is negative 1/2, negative square root 3 over 2. That means your cosine is negative 1/2. Now, if you're not sure about that, the next thing I want you to do is put your calculator in radian mode. So put it in radian mode. We haven't done that very much. And so once you put it in radian mode, then I want you to type cosine and then 4 and then pi. So type in the symbol pi and then divide by 3. And you're going to get negative 1/2. And so that's what that means. And so when you're finding what the cosine and the sine is, that's what you're doing. You're just finding the location on the unit circle of that. And then we're going to see other visualizations as we move along. We'll see some other ways to look at cosine and sine that are interesting. Okay, the next thing that I'm going to talk to you about, we have learned before that cosine is adjacent over hypotenuse when you're dealing with a right triangle, and sine is opposite over hypotenuse when you're dealing with a right triangle, and tangent is opposite over adjacent. Okay, now opposite deals with sine and adjacent deals with cosine. Okay, they both have the hypotenuse there. And so if we're dealing with that, we can say tangent is the same thing as sine over cosine, which would mean, I'm running out of room, opposite over hypotenuse divided by adjacent over hypotenuse, which means opposite over hypotenuse times by the reciprocal. The h's cancel and you're left with opposite over adjacent. And so tangent is the sine over the cosine, so what does that mean? That means that when we come back over here, if I said, okay, what is the tangent of 30 degrees? The tangent of 30 degrees is the sine divided by the cosine, which means the sine multiplied by the reciprocal, which is going to be 1 over square root 3. Simplify that radical. The tangent of 30 is square root 3 over 3. So I want you to write tangent, we'll do tangent 30 square root 3 over 3. So come back over here to your unit circle, and so what you're going to do is you're going to go around the circle now and you're going to write tangents. So tangent of 30 is square root 3 over 3. 45, so if I say tangent 45, it's going to be square root 2 over 2 divided by square root 2 over 2. So you've got a number divided by itself, so that's going to equal 1. For 60 degrees, you're going to have square root 3 over 2 divided by 1/2. And so you can write that out. So you can say square root 3 over 2 times by the reciprocal. So the 2's cancel out, so it's just square root 3. Okay, let's look at the 0 degrees. Tangent of 0 degrees is 0 over 1, which is 0. 90 degrees. Tangent 90 is equal to y over x. What is 1 divided by 0? So we know that 1 divided by 0 is undefined, and so that's actually what we say that the tangent of 90 degrees is. If you want to type this in your calculator, if you're still in radian mode, you need to type in tangent pi divided by 2. If you're in degree mode, you can type in tangent 90, but either way, it's going to give you an error, and that's because it's undefined. Okay, so what's going to happen as you move into quadrant 2 with your tangents? You're dealing with exactly the same numbers that you were in quadrant 1. The only difference is positives and negatives. So at 120 degrees, you're going to have a positive divided by a negative. So your tangent is still going to be square root 3, but this time it's going to be negative square root 3 because of positive divided by negative. On square root 2 over 2, on the 135, the tangent of 135 is going to be negative 1. On 150 degrees, so tangent 150, it's going to be exactly the same as what it was for tangent 30, except you're doing a positive divided by negative, so it's going to be negative. 180 degrees is going to be y over x, which is 0. Okay, so I want you now to pause the video, and I want you to finish the tangents for all of the rest of the angles. You're just dealing with the same numbers that we've already done. Your job that you have to do is just remember about the signs. Think of your location. Okay, when you come back, make sure that you are doing it right, and then we'll move on. Okay, what you should have done for 210 degrees, that one, because it's a negative divided by a negative, is going to be square root 3 over, square root 3 over 3. For 225, because it's a negative divided by a negative, it's going to be positive 1. For 240, it's going to be a negative divided by a negative, so it's going to be square root 3. And you know, one thing you can do is just notice, like, you're just looking at like here compared to here. It's going to be the same except just a sign change, that's all. And so then if I go to 270, that tangent of 270 is going to be 0 divided by negative 1, so that's going to be undefined. And 300, the tangent of that one is going to be the same as it was at 120 or the same as it was at 240, except there's going to be a sign difference because it's going to be a negative divided by a positive, so it's going to be negative square root 3. This one's going to be negative 1, and this one is going to be negative square root 3 over 3. So because of the unit circle, and because knowing where the locations of everything are, let me get to the right page that I want to show you. Because of that, if I have a unit circle and I say, what's the tangent of 45? If you know what the ordered pairs are, then you can tell me that that's 1 without a calculator. You should be able to do all of this by memory by the time we get to the test. So what you want to be able to do is you want to be able to get to, you can just get a piece of paper. So like on your test, you can get a blank piece of paper and you can make your own unit circle. If it's coming out of your head, that's not cheating. So you say, this is 30 degrees, 45, 60, 90, 120, 135, 150, and then you can keep going around. So you've got the 3 sections in each quadrant, and you can say 1/3, or something, that's not 1/3, 1/6, 2/6, which is pi thirds, 3/6, which is pi halves, 4/6, which is 2 pi over 3, 5/6, and pi. And you can keep going around and doing that. But as you're looking at that, so if I'm doing 2 pi thirds, and I can say, well, that's the 60-degree angle. So if I'm thinking about my triangle here, I'm going to go over a little, left, and up a lot. If I'm looking down here at 225, that's going to be my 45, 45, 90 angle triangle. So it's going to be negative square root 2 over 2, negative square root 2 over 2. My tangent will be positive 1. Oops, positive 1. And so you should be able to do any of those without a calculator. Okay, your homework is you are going to, in your book on page 46, there is a blank unit circle. And what you're going to do is you're going to create a new unit circle with all of the information. You need to put your notes away, and I want you to do as much of it as you can by memory or by figuring it out what you've learned. For each angle, you need to have an ordered pair. You need to have it labeled in degrees and in radians. You need to understand that the cosine and the sine are the x and the y, and so label it like on your first quadrant or something. You have on your paper, you have more room to write on the outside of the circle. The circle is smaller. And then you also need to write the tangent for each one. So do as much of it as you can from memory. If you can get the first quadrant, you can get all of it because it's just the same exact numbers. You just have to think about the location. Remember that in the first quadrant, you've got positive and positive, so your tangent will be positive. In the second quadrant, you've got negative and then positive, so your tangent's going to be negative. In the third quadrant, both are negative, so the tangent will be positive because negative divided by negative. In the fourth quadrant, you've got positive and then negative, so your tangent will be negative. So in this quadrant, your tangent is negative, and in this quadrant, your tangent is negative. In this quadrant, your tangent's positive, and in this quadrant, your tangent is positive. And so you need to know all of that. So you do as much as you can from memory, and then whatever you cannot remember and you cannot figure out, then you get your notes and you go back and you'll use that to verify, to check. There's no answer key available on this. You're going to use that to check. You need to use that to make sure you're doing it right. If you have any questions, you need to ask, because this is going to come back. Knowing this is very important when you're doing trig, and it will serve you well in years to come. So basically, your homework should look like this, okay? Oh, I was going to tell you one other thing about the tangents. It's easy to remember that the undefined are at the 90 and the 270, because if you look at the y-axis, it has a slope that's undefined. If you look at the x-axis, it has a slope of 0, so it's easy to remember that the tangent there is 0. And so that's just a way to remember if you get confused or mixed up or something. But basically, your homework should look like this paper as well. And so your notes and your homework should essentially look the same by the time you're finished. Okay, what you're going to do as far as turning in, you're going to turn in 2 things. Well, it's going to be in one assignment. You're going to turn in, first, your notes. So what we have done during this lesson, it's going to be the unit circle on the paper that I gave you. And then after that, you're going to take a picture of your homework, so where you created the unit circle yourself. And then you'll submit that as one assignment for 8-5. I was going to have you do a different assignment that I've done in years past, but I've decided I'm not going to have you do that. I'm going to instead just have you recreate this unit circle. If you have questions, make sure you let me know, and then we'll be doing an activity next time that will help solidify this understanding.